Hello everyone, welcome to Pharmacy Lectures. Today we are going to discuss about Introduction to Isoprene Rule. First, let's discuss about terpenes and terpenoids. Terpenes and terpenoids are a group of natural compounds that are derived biosynthetically from isopentenyl pyrophosphate and dimethyl allyl pyrophosphate. From these two molecules, all the terpenes and terpenoids are formed. The term terpene was given to the compounds isolated from turpentine, a volatile liquid isolated from pine trees. The difference between these two terms, terpenes and terpenoids, is that compounds belonging to terpenoid category contain additional functional groups may be derived from sulfur, phosphorus, or oxygen, whereas terpenes are solely composed of carbon and hydrogen only. Let's see in the example of limonene and menthol which one is terpene and which one is terpenoid. Here limonene, it is solely composed of carbon and hydrogen only. That's why it is categorized under terpene, whereas menthol, it contains additional oxygen atom other than carbon and hydrogen. That's why it is categorized under terpenoid. Also, the term terpene and terpenoid are used synonymously throughout various books, and in our upcoming lectures we will also use these two terms synonymously. Terpenoids form a large and structurally diverse family of natural products derived from C5 isoprene units. Means terpenoids are formed from C5 isoprene units, and the terpenoids are joined in head to tail fashion. This is a C5 isoprene unit, and the repeating unit of C5 isoprene molecules will give rise to terpenoids. This is isoprene molecule, a separate molecule. Terpenoids are produced by plants, animals including humans, and microorganisms. Most terpenoids are further modified by cyclization reactions. There can also be acetylation reaction, methylation reaction, hydroxylation reaction, and other various reactions. But the head to tail arrangement of the units can usually still be recognized. Example menthol, bisabolin. In various other structures also, we can identify the head to tail attachment. Let's see here. Let's see here the head to tail attachment in menthol and bisabolin. In menthol, this segment, the branched segment, is the head segment, whereas the unbranched segment is the tail segment of one isoprene unit. Of another isoprene unit, this branched segment is head segment and the unbranched segment is tail segment. The attachment occurs between the carbon of head segment and the carbon of tail segment. Here the attachment will be there in between the carbons of head segment and tail segment in menthol. In bisabolin structure also, this branched segment is head whereas unbranched is tail. Here also this branched is head and the unbranched is tail, and the attachment is in between the carbons of head segment and tail segment, in between these two isoprene units. And of this isoprene unit and this isoprene unit, let's see, this is the carbon of head segment, this is the carbon of tail segment, and there is attachment. So obviously we can see here the head to tail arrangement of the isoprene units. Now let's discuss about classification of terpenoids. Terpenoids are classified on the basis of the isoprene units they contain. If they contain a single isoprene unit, they would be categorized under hemiterpenes. The example is isoprene molecule itself. If the terpenoid or terpene contain 10 carbons or 2 molecules of isoprene, and then it will be categorized under monoterpenes. If 3 isoprene units are attached to each other and the terpene is formed, it is categorized under sesquiterpene. If there is attachment of 4 isoprene units, then it would be categorized under diterpene. 5 isoprene units attached to each other, sesquiterpenes. If there is attachment of 6 isoprene units, it will be triterpenes, and if 8 isoprene units, it would be tetraterpenes. The attachment process for the formation of C10, C15, C20 and C25 is usually the same. For the formation of C15 derivative, there is attachment of IPP to the C10 derivative, means 10 plus 5, 15. For the formation of C20 terpenes, there is attachment of IPP to the C15 sesquiterpene, and it will be formed C20 derivative. For the formation of C25 terpene or C25 terpenoid, there is attachment of IPP to the C20 derivative, and C25 derivative would be formed. But in the formation of C30 and C40 derivatives, there is not this usual attachment of IPP and formation of the corresponding terpenoids. Rather, in the formation of this C30 derivative, it is formed by addition of 2 molecules of C15 derivatives. One molecule of C15 derivative plus another molecule of C15 derivative. Then this C30 derivative triterpenoid will be formed. C15, it can be called sesquiterpene, or we can call it farnesyl pyrophosphate, FPP. 2 molecules of FPP will give rise to first squalene, and further cyclizations in the squalene will give rise to various steroids. And the attachment here to this C10 derivative of the IPP, it is head to tail attachment. The attachment of IPP to this C15 derivative is head to tail. The attachment of IPP to this C20 derivative is head to tail, but here the attachment of farnesyl pyrophosphate to another farnesyl pyrophosphate is tail to tail attachment. And in the formation of this C40 derivatives also, the attachment of one C20 derivative to another C20 derivative is tail to tail. That's another difference in between the formation of these two terpenoids, triterpenoids and tetraterpenoids. So terpenoids can be classified on the basis of isoprene units they contain. For example, hemiterpene, monoterpene, sesquiterpene, diterpene, sesquiterpene, triterpene and tetraterpene. Now let's discuss about isoprene rule. Isoprene rule states that the terpenoid molecules are constructed from 2 or more isoprene units. Combination of 2 or more isoprene units will give rise to terpenoid. In 1887, Otto Wallach pointed out that the terpenoids can be built up of isoprene unit. He also states that all terpenoids are derived from one monomeric structural unit, isoprene. Hence, they are referred to as isoprenoids. The empirical formula given was C5H8. Uh, Isoprene rule also states that on thermal decomposition, isoprenoids yield isoprene. If we give heat to isoprenoids, we must get isoprene molecules. Another statement is also there. It states isoprene undergoes polymerization to yield various terpenoid. You can see this is isoprene, and attachment of various molecules of isoprene can give rise to terpenoids. This is another statement of isoprene rule. Thus, the divisibility into isoprene units may be regarded as a necessary condition to be satisfied by the structure of any plant synthesized terpenoid. So this was the core statement of isoprene rule. For a molecule to be satisfied as a terpenoid, it must undergo a decomposition to yield isoprene units. Now there is one more rule which further elaborates or extends the isoprene rule. It is a special isoprene rule given by Ingold in 1925. Ingold pointed out that the isoprene units in natural terpenoids were joined in head to tail fashion, the head being the branched end of isoprene. Ingold states, yes, the terpenoids are formed from attachment of isoprene units, but the attachment is not random, the attachment is specific. How specific is the attachment? The attachment is specific such that the tail end carbon is attached to the head end carbon, which can be seen in this structure. This divisibility into isoprene units and their head to tail union may conveniently be referred to as special isoprene rule. So isoprene rule only states that terpenoids are formed from isoprene units, and isoprene units can undergo polymerization to yield terpenoid. But special isoprene rule further states that isoprene units from their head to tail union will give rise to terpenoids. And one more important thing about this isoprene rule: applying special isoprene rule in the carbon skeletons of open chain and closed chain monoterpene and open chain sesquiterpene. Let's see if we try to apply the special isoprene rule, can we get the head to tail attachment or not? For example, here in acyclic sesquiterpene, this head, this tail, this head, this tail, there is attachment of carbon of tail end to the head end. Yes, there is attachment of carbon of this head end to the tail end carbon. Yes, we can see the head to tail attachment in acyclic sesquiterpene. In this cyclic monoterpene, let's see, this is the head end, this is the tail end, this is the head end, this is the tail end. We can see the attachment of carbon of tail end to the head end carbon. In monocyclic monoterpene also there is head to tail union. In acyclic monoterpene also there is head to, this is the head to tail union. This rule, special isoprene rule, proved very useful, but can only be used as a guiding principle, not as a fixed rule. Special exceptions occur to this special isoprene rule, head to tail union rule. For example, in carotenoids, there is not head to tail union during the formation of carotenoids. During the formation of squalene, there is also not head to tail union, rather there is tail to tail union at their center. And there are some terpenoids whose carbon content is not a multiple of 5, means they can have, for example, for molecule to be diterpenoid, it must contain 20 carbon atoms. But a molecule may be diterpenoid, but it may contain 30 carbon atoms. It can be like that. The other carbon atoms can be arised from acetylation, methylation, benzoylation, from other substitutions. Those carbon atoms can come there. So one more exception is there, that some terpenoids may not have a multiple of 5 isoprene units and cannot be divided into isoprene units. So these two are the exception of special isoprene rule. One more isoprene rule is there. It is biogenetic isoprene rule. First, let's see what is biogenetic isoprene. The biogenetic isoprene unit is 3-methyl but 3-enyl pyrophosphate, or IPP. You can see 1, 2, 3, 4. At position number 3 there is methyl, so 3-methyl, this is butene, but 3-ene. At position number 3 there is this double bond, but 3-enyl pyrophosphate. This is the biogenetic isoprene, but its participation in the biosynthesis of terpenoids involves its equilibration and also the presence of the appropriate enzyme. Equilibration with whom? Equilibration with 3-methyl but 2-enyl pyrophosphate. Equilibration with this molecule. 1, 2, 3, 4. At position number 3 there is methyl. At position number 2 there is alkene. So 3-methyl but 2-enyl pyrophosphate, or beta-beta dimethyl allyl pyrophosphate. There must be equal numbers of, or equal amount of, these two molecules, 3-methyl but 2-enyl pyrophosphate DMAPP and 3-methyl but 3-enyl pyrophosphate IPP. And also there must be the appropriate enzyme to conduct the reaction for the synthesis of terpenoids. Here beta-beta dimethyl allyl pyrophosphate is written. The allyl group means this segment, it is called the allyl group. CH2 CH double bond CH2, it is called allyl group. This isomerization is stereospecific, means IPP can go into DMAPP and DMAPP can go into IPP. HA being the proton that is eliminated. Let's see here the reaction. Also the newly formed methyl group is trans to the methyl pyrophosphate. Here IPP can be isomerized to DMAPP and DMAPP can be isomerized to IPP. And during this isomerization we can see here there is elimination of this proton, and this proton can be attached here, and here double bond can be created here, and IPP can be converted into DMAPP, and DMAPP can also be converted to IPP. The double bond can shift here, the hydrogen can shift from here to here, this carbon, and IPP to DMPP can be transformed. The biogenetic isoprene rule, it states that members of the isopentane group means the terpenoids should be derivable from simple hypothetical precursors such as geraniol, farnesol and squalene, and these geraniol, farnesol, squalene, they are formed from these two molecules IPP and DMPP and the appropriate enzyme. Let's see the structures of geraniol, farnesol and squalene. Geraniol, it is a 10 carbon containing monoterpenoid. Farnesol is 15 carbon containing sesquiterpenoid, and squalene, it is the 30 carbon containing triterpenoid. The biogenetic isoprene rule also includes compounds that originated from regular isoprenoid precursors, which by rearrangement or degradation give products that no longer obey the isoprene rule. Means in the isoprene rule previous and special isoprene rule, these compounds were not included because in these compounds it is very difficult to identify where is the head to tail union. The biogenetic isoprene rule do not states the head to tail union. It states that the terpenoids are formed from biogenetic isoprene units through the various intermediates like geraniol, farnesol, squalene. And that is the statement of biogenetic isoprene rule. So it includes various terpenoids, including these compounds like gibberellins, where it is very difficult to identify the head to tail attachment. So this was all about the introduction to terpenes and isoprene rule. If you have any problems, please comment. Thank you for watching. See you in next video.